Welcome to qnawire.
Okay, in this problem we have a room with dimensions 5 by 6 by 2.4 meters. This room's at a temperature of 24 degrees Celsius and it has a relative humidity of 65%. We were asked to find the total mass of the water in this room. So what we can do is we can use table 18-2 to give us the pressure per degree Celsius. Now, because we're between 20 degrees and 25 degrees, we have to do some interpolation. So we can use from the table values for 25 degrees Celsius and 20 degrees Celsius. Those values are 3,170 Pascal and 2,330 Pascal. So to interpolate, we take the difference between these over the difference in the temperatures, 25 and 20, to give us pascals per degree Celsius, which will end up being 168 Pascal per degree Celsius. So thus, the saturated vapor pressure because at 20 degrees Celsius it is 2,330 Pascal. We now can use the interpolation. So we start with that plus our conversion factor, if you will, the 168 Pascal per degree Celsius times 4 Celsius, because that's how far away it is from the 20 degree in the table. And if we do this quick number crunch, we get 3,000 Pascal. This is our pressure. Now that we have pressure, volume, and temperature, we can use the ideal gas law to find the number of moles. So remember, PV equals nRT, where n is the number of moles. Thus, it's the case that the number of moles is just PV over RT, where we know everything. We interpolated to get the value of P from the table. So putting in some numbers, we have 0.65, this is the humidity, 3,000 Pascal, 5 times 6 times 2.4 gives us the volume of the room in meters. Of course, we have the gas constant, 8.314 joules per mole Kelvin. And our temperature, which needs to be in Kelvin, so you have 273 plus 24 K. And once we crunch this, we have 56.8 moles. Once we know the number of moles in the entire room, we know it's water, so we can say the actual mass of that water is just its molar mass times the number of moles. 56.8 mole times 0.018 kilograms per mole, which we can just look up for water, gives us about exactly 1 kilogram of water. So that was a little idealized to get a nice answer, but that's it. So just to recap, we used the table, and because the value was between two elements in the table, we had to do a linear interpolation. Doing that, we found the pressure, and then we used the ideal gas law to get number of moles, and from number of moles, we got the mass for H2O. And that's it.